Lesson on Circuit Analysis for Honors Physics. Here's a compound circuit. You can see we have resistors of 4 ohms, 3 ohms, and 6 ohms connected to a 12-volt battery. But what's the current and voltage for each of these resistors? Otherwise, how much current goes through this 4 ohm resistor, through this 3 ohm, through this 6 ohm, and what's the voltage across each resistor as well? Let's take a look at the steps for solving such a problem. Steps for solving circuit problems. First step is we want to follow the current to determine which resistors are in series and which are in parallel to then calculate the total resistance of the circuit. Once we know the total resistance of the circuit, we can calculate the total current flowing through that entire circuit by using Ohm's law. We then want to determine the current through and the voltage across each resistor by following that current and using Ohm's law for each resistor in our circuit. So we're back to our circuit. We want to determine the current and voltage for each resistor here. We have a 4 ohm, 3 ohm, and 6 ohm. Well, if we follow the current here flowing through our circuit, we see that all the current will go through the 4 ohm resistor. That means this 4 ohm resistor is in series with our battery. If we keep following that current, we'll see that it splits. Some current will go this way through the 3 ohm, and some of it will go down this way through the 6 ohm. This is an indicator that the 3 ohm and 6 ohm resistors are in parallel. And then our current will keep flowing through our circuit. So let's combine our 3 and 6 ohm resistors in parallel and add them to our 4 ohm in series. So for the two in parallel, let's do 1 over R parallel, which is just adding the inverses then, which is going to be 1 over 3 ohms plus 1 over 6 ohms. And if we do common denominator on this, we'll get 3/6 equal to 1 over R. So hence the equivalent resistance for those two resistors in parallel will be 2 ohms. So this is now like our 3 ohm and 6 ohm resistors in parallel are one resistor of 2 ohms that is in series with this 4 ohm resistor. So let's add those. So we know adding resistors in series is just the sum. So this is just going to be 4 ohms plus 2 ohms and giving us a total resistance of 6 ohms. So our entire circuit, even though we have 4 ohms, 3 ohms, and 6 ohms, altogether these resistors provide an equivalent resistance of 6 ohms to our 12-volt battery. Now we can further find the total current flowing through our circuit by using Ohm's law as I equals V over R. So we have a 12-volt battery, a total resistance of 6 ohms offered by those three resistors gives us a total current of 2 amps. Now that we know 2 amps of current flow through our circuit, let's follow it through our circuit. So here's our 2 amps flowing. We can see that as these 2 amps get to this point right here, all of those 2 amps have to go through the 4 ohm resistor. There's only one path for the current to take. Now at this point we know the resistance is 4 ohms and has a current of 2 amps. We can determine what the voltage is across this resistor by using Ohm's law. Let's do it. So for the 4 ohm resistor, we see Ohm's law here. So we have 2 amps will equal the voltage across that resistor divided by its value of 4 ohms. And you can see that 4 times 2 will give us a voltage drop of 8 volts. Now if we continue our current, we noted that at this point the current's going to split. But what will the current be through the 3 ohm resistor and through the 6 ohm resistor? Well, if we look at the voltage for a moment, we know the battery provides 12 volts, but we've already lost 8 volts to the 4 ohm resistor. So that means we have 4 volts left to go across these resistors in parallel. And since they're in parallel, that means both of these resistors will get a voltage drop of 4 volts. So let's use that with the resistance values to determine the current through each resistor. For 3 ohms, using Ohm's law, we have 4 volts divided by 3 ohms, which will give us 4/3 of an amp or 1.33 amps. By further applying Ohm's law to the 6 ohm resistor, we get 4 volts over 6 ohms, which is 0.67 amps. Now if we look back at our diagram here, I've labeled 1.33 amps through the 3 ohm and 0.67 amps through the 6 ohm. If you notice, 1.33 plus 0.67 is the 2 amps. So as 2 amps flow here, it splits. 1.33 amps go through the top and 0.67 amps go through the bottom. They then recombine here so that we now have a current here of 2 amps. So no current is lost, just different amounts of current go through different parts of our circuit. One could also note that through the 3 ohm resistor, it gets twice the amount of current than the 6 ohm resistor does. And you've probably heard that old phrase, current follows the path of least resistance. So more current will go through the lower resistor as compared to the larger resistor. And since these are in a ratio of 1 to 2, we'll get 2 times the amount of current through the smaller resistor. Here's our extension problem revisited. See if you can determine the total resistance of our circuit, and then follow the path of current to figure out the current through each resistor and the voltage across each resistor. We can label these currents as I1, I2, I3, and I4 respectively, and the voltage drops as V1, V2, V3, and V4 respectively. Be sure to label your diagram with the appropriate notation for current. Current goes through a resistor, and voltage is established across a resistor using these symbols. Pause the video now to solve on your own, and then check for the solutions. By combining these two resistors, 30 and 50, in parallel, I got 18.75 ohms for their total resistance. Adding that to 20 and 20 in series gives us a total resistance of 58.75 ohms. Applying Ohm's law with our 10-volt battery will give us a total current of 0.17 amps. If we follow the current of 0.17 amps, all of it will go through this first resistor because there's only one path. Once it gets to this point, it will split. Back here it will recombine and all 0.17 amps will go through this last resistor. By knowing this, you can determine V1 and V4 by applying Ohm's law to these two resistors. This gives us 3.4 volts for both of these voltages. Now in order to find I2 and I3, we need to know what the voltage drop is across these two resistors in parallel. Well, since we have 3.4 volts and 3.4 volts here, and a 10-volt battery, we can see that it's going to be 3.2 volts for V2 and V3. Thus we can see the total voltage of 10 volts is dropped across the entire circuit. 3.4 volts, 3.2, and then our last 3.4 volt drop add up to 10. Now we can find I2 and I3 by applying Ohm's law to 50 ohms and to the 30 ohm resistor. And with some rounding, we get I2 to be 0.11 amps and I3 to be 0.06 amps. Notice they add up to be 0.17 amps so that we don't lose any current through our circuit. Thank you for watching, and see you in class.